Hello everyone and welcome to this video where we will be learning to work with text files or more specifically CSV files because that's where most of the times our data sets will be saved. Okay. So what I have done for the purpose of this demonstration, I have used this CSV module that is present in Python, and I have used this to create a file called accounts.csv which will be written on my local drive. So let's take a look at that file first, and then we will read that file as a data frame using pandas. Okay, so this is the file that I have created by executing that code. So as you can see in this file, there are no column names, but there are three columns present. The first column has some numbers in it. Then there are these names of people, and then there are certain other numbers that are present in this file. So let's see how can we work with this information. So we will go back to our notebook here, and what I'm going to say is first I will start by importing pandas as PD, okay, which is the regular step that we execute every time. And then I'm going to use a read underscore CSV function, which is present in pandas. And what we have to do here is we just have to give the name of the CSV file that is present in our local drive in our folder. And as you saw that the column names were not present in that file, and which is very inconvenient. So I'm going to give some names which will basically the keyword names will be used to define the column names of the file that we are reading in at this moment. So the first column was basically the account number, the second column was the name of the person, and the third column is basically the balance that those people hold in their account. Okay, so we will store this in the data frame, and we are going to execute that code and see what happens once it's done. So as you can see, the CSV file that I showed you on my local machine is now read in as a data frame, and that's how it looks like. Okay, so this is how very simply you can use the read underscore CSV command from pandas to read CSV files as data frames. Now let's try to write this information back into a CSV file and see how that functionality works. Okay, so for that what I'm going to do is I will be using the to underscore CSV command which is present in pandas, and I'm going to give it a name, a different name to this particular file. Okay, and while I am writing this file, I'm saying index is equal to the keyword false. Okay, and let me tell you what will happen with that. So basically when I write this data frame as a CSV file, I don't want this column which contains the index names to be carried over, and that is why I said index is equal to false. And as a result of executing this, if I go back to my folder here, I see that basically a CSV file was created with the column names that I had given in my code. Okay, and so that's what it has done. .csv. Okay, that's what this command will do. Okay, and so now what we've seen is that how do we read a CSV file and how do we write a CSV file from a data frame in our notebook. Okay, now very often we don't really create data sets on our own, but we work with existing data sets, and a lot of times these data sets might not be available on our local machine, but they might be available through a known link or a location, okay, that we are aware of, a URL for example. So now I'm going to work with something more realistic. So basically we will be working with this well-known Titanic data set, and Titanic data set, as we all are possibly aware of, contains the information about the passengers who were on board the Titanic ship when it got struck with disaster, and it has information about the fate of those passengers. So in order to do that, what I'm going to do is I will be creating this new file, Titanic. I will be using this command that we just saw right now. And inside this, I'm going to use the link, which is basically this link online, which has the information, or it has the data set location, which can be traced with this link. So I'm going to copy this link, and I will paste it in my read underscore CSV command, and let's see what happens. Okay, so after that, looks like that the Titanic dataset has been successfully read. Now, in order to check that, what is recommended is that we try this head command. We don't want to print the whole file because it might be possible that the file might be really big in terms of the number of rows that it has. And so I use this command head, and by default, it gives me the top 5 rows in my file. Okay, and similarly, if you wanted to see the bottom 5 rows, you could have said tail, which is also a command that is inbuilt into pandas. Okay, so these are all functions that can be called on the existing data frames, and Titanic right now is our data frame. Now, as you see, there's something not so good about the file that we have read. The column names look a little bit weird. For example, the first column, which is the name of the passengers, is read as something like unnamed :0, which is really strange, and we will like to change that. Also, passenger class is a really long column name, and ideally we would like to shrink that and make it shorter. So let's see how we can do that. Okay, so what I'm going to do for that is I will be using another command, which is basically using the columns Titanic.columns, and I'm going to define that as the name of the columns as a list input that I will give to this particular attribute. So I will say name, which is my first column. The second column will be survived, which is basically whether they survived or not. The third column is the sex or the gender of these people. And the fourth column is the age. And the next column should be defined as class, because passenger class is a really long name to have. So let's see what happens once we do that. And then I'm going to call the heads function once again, and there you go. So this gives me better or more suitable names, column names, as we desired. Okay, now let's move on a little bit from here. So this is how basically you can read any existing data set that you are interested in working with. Now from here, let's try and do some very basic uh, exploration on this data set that we have just read. So the first function that we will be using here is the describe function. And Titanic.describe. Okay, here we are. So let's look at the output and understand what happened here. Now, when I call the describe function, you see that I just get some descriptive statistics for age only. Now, why was that the case? This happened because by default, describe only gives the descriptive statistics for the numerical columns in our data set. And in this data set, age is the only numeric column at this point in time. So that is why we got this output. Now let's try and understand this output a little bit better. In this output, you see that the count is 1046, which is less than the number of rows in the total data set, which was 1308. And the reason for that is, as you can see, some of the age values are missing in this data set. And by default, pandas is really smart, and it calculates all the descriptive statistics only on the non-missing elements or values of a particular column. And that is why mean, standard deviation, the interquartile range, everything is calculated on 1046 values of age, which are essentially the non-missing values. Okay, so that's that. Now let's see what would happen if we were to call the describe function on one of the categorical fields in my data set. Here we are. So we get a very different type of an output. And what this says is that the number of counts in the data for survived is 1309. The number of unique values that it takes is 2. And then top is basically telling you that out of the two values, which are the more frequent values? And the answer for that is no. We know that survive takes value yes and no. And the frequency for no is 809 out of 1309, which is the total number of counts that we have in our data set. So that's what describe function does on categorical fields. Okay, so before I end this video, I want to briefly show some more interesting functionality on this particular data set. So we know that visualizations are a great way of exploring the data. Okay, and I want to briefly talk about some inbuilt visualization in pandas. So what happens is that pandas has many inbuilt visualization capabilities that are implemented through this support functionality of what is known as matplotlib. So what we need to do is we need to enable the matplotlib support in pandas before we can call those inbuilt visualizer. So matplotlib is enabled after this particular piece of code, and from there I will just show you one of the basic functionalities, which is how can you create a histogram using pandas. So what I have done is I have called a hist function on Titanic, and by default the hist function will build the histograms of all the numeric columns in the data set. And as we already discussed, age is the only numeric column in this particular data set. So because of that, we just got one histogram here. Now we know what the histogram shows. Histogram basically shows us the frequency distribution of the particular column that we are working with. And on the x-axis, you have the bins, which have been created for the age column. So age is somewhere between 0 and 80. And on the y-axis, we have the frequency for each of the bins. Okay, so you can see where most of the people's ages are concentrated, somewhere around 20 to about 30 some years. Okay, which is also something which we have seen from the describe function. Okay, so that's all for this video, and look forward to seeing you in other subsequent videos and classes.